Okay, and using and doing trigonometric derivatives before, we did some very basic ones. So these are the rules once again at the top of the page, and you really do have to have these memorized or be able to figure them out fairly quickly. So look at the patterns, and I've gone through it once before. The more you do these, the easier it is going to be to remember them. We're going to use the power rule. So before I showed you with the product rule, and there becomes a pattern with these. So what happens, and it's kind of like a play off the chain rule. If you were equal to, let's do it this way. If you were equal to sine x, that means f of u would be equal to u cubed. So f prime of u, using the chain rule, would be 3 u squared times the derivative of u, which is u prime. The same thing is going to happen here. And I know right now most people don't like this idea of the u substitution. But I need to keep showing to you because later on you're going to have to be familiar with it. So the same thing's going to happen here. To find the derivative of this, I'm going to do f prime of x. Remember, this is saying sine x cubed. The x is not cubed, the sine of x is cubed. So I'm going to bring the 3 out front, and I get 3 sine x, that's going to be squared, and then the derivative of sine x is going to be cosine x. So typically it's written as f prime of x equals 3 sine squared x cosine x. And we could have come up with the same answer using the product rule. So the second one here, with y, I would have dy dx, bring the 5 in front, take this down 1 degree, so it'd be cosine to the 4th x, and then multiply this by the derivative of cosine, which becomes negative sine x. So dy dx is going to equal negative 5 sine x cosine of the 4th x. And it doesn't matter, I could have written this negative 5 cosine to the 4th x times sine x. So here's tangent squared. So the derivative is going to be equal to 2 tangent x to the first power, and then the derivative of tangent is secant squared x. So the power rule comes in pretty handy instead of having to use a product rule. So cosecant to the 6th. So the derivative is going to be 6 cosecant to the 5th x. And then the derivative of cosecant is going to be negative cosecant x cotangent x. To clean this up a little bit, I get y prime equals negative 6 cosecant to the 6x cotangent x. So when I've written this, type this one secant theta to the 4th power, it's the same thing as saying secant to the 4th theta. It's just the 4th power. So g prime of theta is going to equal 4 secant cubed theta, and then the derivative of secant theta is secant times tangent. So g prime of theta is equal to 4 secant to the 4th theta tangent theta. And here's cotangent to the 7th, so I did get a little bit ridiculous with it, but it's to show you the examples and how this works. So that means dy dx, 7 cotangent to the 6x, and then the derivative of cotangent would be negative cosecant squared x. And there's nothing wrong with it like that. I'm just going to go ahead, and I like the negative up front. So negative 7 cotangent to the 6x cosecant squared x. So now the u substitution is going to be a little bit different down here. All of these up here had just an x, just plain x or theta with the trig. This one now has 6x. So this is going to be a little bit different. if, let's go back to this. If I let u equal 6x, du dx is going to equal 6. But now I also have this sine squared. So it's going to take on a little bit different form. I'm going to have y prime is equal to 2 sine 6x, and then the derivative of 6x, well, let's do it this way, times cosine 6x. But then we also have to multiply by the derivative of 6x. So y prime is going to equal 12 sine 6x cosine 6x. So that's what's different here. It's the same as what we did up here. You're using a power rule, multiplying by the derivative of sine, but then multiplying it by the derivative of 6x. So let's try it with this one here. So f prime of x, my exponent is 5, so the 5 comes out front. Cosine to the 4th, 3x over 7. The derivative of cosine is negative sine, 3x over 7. Multiplied by the derivative of 3x over 7, which is going to be 3 over 7. Just going to clean it up a little bit, so I get f prime of x equals, there's a negative 5 and a 3/7 is going to be 15 over 7. Cosine to the 4th, 3x over 7, and sine 3x over 7. So a little bit different here. It's got this 4x squared minus 5x, so it's just getting a little bit bigger, but it's still the same process. So h prime of x is equal to 3 comes in front, sine squared of 4x squared minus 5x times the derivative of sine, which is going to give you cosine. If I put that parentheses there, there's going to be too many parentheses. Let me clean that up. Okay, 4x squared minus 5x. And then cosine 4x squared minus 5x. And then multiplied by the derivative of 4x squared minus 5x, which is going to be 8x minus 5. Not really making it any simplified. I'm just going to write it in the order that you typically see it. We'll see a 3. We'll see the 8x minus 5. Then we'd see a sine squared 4x squared minus 5x. And then you'd see a cosine 4x squared minus 5x. Now the last one's going to be a little bit longer because I'm going to have to use a quotient rule. So let me do it so there's not too much going on. Let's first find the derivative of this 2x plus 1. So if u is equal to 2x plus 1 over 3x, du dx, low d high minus high d low, all divided by low squared. So du dx equals 6x minus 6x minus 3, because that's negative 2x times 3 and a negative 1 times 3, over 9x squared. So dy dx is equal to negative 3 over 9x squared, which is equal to negative 1 over 3x squared. So I'm just going to write this here. So if u is equal to 2x plus 1 over 3x, du dx is equal to negative 1 over 3x squared. Save me some space. I don't have a lot of room on here. So then my derivative, dy dx, the exponent comes in front, cosine of 2x plus 1 over 3x, times the derivative of cosine, so negative sine 2x plus 1 over 3x. I'm going to make this a bracket. Times the derivative of this function here, so times negative 1 over 3x squared. Just be careful now. I have a negative and a negative, so I know it's going to be positive. I'm going to put the 2 multiplied by 1 over 3x squared. So 2 over 3x squared times the cosine of 2x plus 1 over 3x times the sine of 2x plus 1 over 3x. That should be the answer. Okay, the back of this has got some different types of problems, and I'm not going to do those today. I will do those at a later date. These are still going to be chain rule, but then there's also something called implicit differentiation, and you'll notice I've got x's mixed in with y's. So that's going to be a different type of differentiation that we do also in Unit 3.